Welcome! This video will provide an overview of AWS container services. You may be thinking, what are containers? Containers are a method of operating system virtualization. Containers are smaller than virtual machines and do not contain an entire operating system. Instead, containers share a virtualized operating system and run as resource-isolated processes. Containers offer several benefits. First, they support repeatability. Additionally, containers deliver environmental consistency because the application's code, configurations, and dependencies are packaged into self-contained environments. Next, they can help ensure that applications deploy quickly, reliably, and consistently, regardless of the deployment environment. Lastly, in terms of space, container images are usually an order of magnitude smaller than virtual machines. Spinning up a container happens in hundreds of milliseconds, resulting in faster launch times than traditional virtual machines. In order to understand containers, it's helpful to know a little bit about Docker. Docker is a software platform that packages software, such as applications, into containers. Docker is installed on each server that will host containers, and it provides simple commands that you can use to build, start, or stop containers. Containers are created from templates called Docker images. Containers have everything that an application that you want to run needs, including libraries, system tools, and the application code, as well as any runtime libraries. Many people who are first introduced to the concept of a container think that the containers are exactly like virtual machines. However, there are some key differences. One significant difference is that virtual machines run directly on a hypervisor, while containers run on any operating system if they have the appropriate kernel features to support Docker host software and the Docker daemon is present. The right of the diagram shows a virtual machine VM-based deployment. Each of the three EC2 instances runs directly on the hypervisor that is provided by the AWS global infrastructure. Each EC2 instance is a virtual machine. In this VM-based deployment, each of the three apps runs on its own VM, and each VM provides process isolation. The left of the diagram shows a container-based deployment. Here you see that only one EC2 instance runs a virtual machine. The Docker engine is installed on the Linux guest OS of the EC2 instance, and that there are three containers. In this container-based deployment, each app runs its own container, which provides the process isolation, but all the containers run on a single EC2 instance. The Docker engine is present to manage how the containers interact with the Linux guest OS. And it also provides central management functions throughout the container lifecycle. In an actual container-based deployment, a large EC2 instance could run hundreds of containers. Given what you now know about containers, you could launch one or more Amazon EC2 instances, install Docker on each instance, and manage and run the Docker containers on those Amazon EC2 instances yourself. While that's an option, AWS provides a service called Amazon Elastic Container Service, or Amazon ECS, that simplifies container management. Amazon ECS is a scalable, high-performance container management service that orchestrates the running of Docker containers. It manages the fleet of nodes, or EC2 instances, that run your containers, removing the complexity of managing the infrastructure yourself. Amazon ECS provides a familiar set of features to anyone who uses the EC2 service, including elastic load balancing, security groups, EBS volumes, and IAM roles. Let's look at the role Amazon ECS plays with regards to containers. To prepare your application, you create a task definition, which is considered a blueprint for your application. Task definitions specify details such as which containers should be deployed to run the task. You specify the number of tasks that will run on your cluster, and Amazon ECS Task Scheduler is responsible for placing tasks within your cluster. When Amazon ECS runs the container based on your task, it places them on an ECS cluster. When you choose the EC2 launch type, the cluster consists of a group of EC2 instances, each of which is running an Amazon ECS container agent. In the example here, the Amazon ECS task scheduler has received a request to run a task that will require 3 instances of container A and 2 instances of container B. Amazon ECS places these 5 containers on the EC2 instances and the ECS cluster. They're distributed in a way that accounts for the CPU and memory capacity available on the cluster nodes. When you create an Amazon ECS cluster, you need to decide the type of cluster you want. You need to ask yourself, do you want to manage the cluster? If you answer yes, you'll have a more granular control over the cluster, and the cluster will run on EC2 instances that you manage. To manage the cluster yourself, choose either the EC2 Linux plus networking or the EC2 Windows plus networking cluster option. You'll need to specify details about the EC2 instances that will make up your cluster. The same details you specified when launching a standalone EC2 instance. If you don't want to manage the cluster yourself, choose the Create a Networking Only cluster option. Networking only Amazon ECS clusters are powered by AWS Fargate. With the Fargate launch type, the cluster that will run your container will be managed by AWS. With this option, you only need to package your application in containers, specify the CPU and memory requirements, define networking and IAM policies, and launch the application. You do not need to provision, configure, or scale the cluster. It removes the need to choose server types when you decide to scale your clusters or optimize cluster packaging. The Fargate option enables you to focus on designing and building your applications. Next, we'll discuss an alternative container service to Amazon ECS. However, before we begin, it's important to have a general understanding of Kubernetes. Kubernetes is an open source software for container orchestration. Kubernetes enables you to deploy and manage containerized applications at scale. With Kubernetes, you can run any type of containerized application by using the same toolset in both on-premise and your data center, including the cloud. Kubernetes can work with many orchestration containerized technologies, including Docker. Because it is a popular open source project, a large community of developers and companies build extensions, integrations, and plugins that keep the software relevant, resulting in new and in-demand features being added frequently. Kubernetes also automates container provisioning, the networking configuration of containers it deploys and manages, the load distribution of containers, and scaling to handle application load. You may be thinking that you can launch one or more Amazon EC2 instances, install Docker on each instance, then install Kubernetes on the cluster, all while being able to manage the Kubernetes instances yourself. While that is an option, Amazon Elastic Kubernetes Service, or Amazon EKS, significantly simplifies the management of Kubernetes clusters. Amazon EKS makes it easy for you to run Kubernetes on AWS without needing to install, operate, and maintain your own Kubernetes control plan. Amazon EKS is certified Kubernetes conformant, so existing applications that run on upstream Kubernetes are compatible with Amazon EKS. It supports Linux and Windows containers, and it's compatible with Kubernetes community tools and many popular add-ons. You may be wondering why Amazon offers both Amazon ECS and Amazon EKS, as they are both capable of orchestrating Docker containers. Well, the reason that both services exist is to provide customers with flexible options. You can decide which option best matches your needs. One challenge of deploying applications on containers is keeping track of storing and managing all those containers. To keep addressing this challenge, AWS provides the Amazon Elastic Container Registry, or Amazon ECR service. It is a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy Docker container images. It is integrated with Amazon ECS, so you can store, run, and manage container images for your applications that run on Amazon ECS. When you specify the Amazon ECR repository in your task definition, Amazon ECS will retrieve the appropriate images for your applications. Amazon ECR supports team collaboration, access control, and third-party integration. And it's also possible to use Amazon ECR images with Amazon EKS. Thank you for watching. We'll see you in the next video.